So we're going to start this section off with the three logarithm properties. Make sure you write these down on your worksheet or in your notes so that you have access to them as we're working through this section. The three properties are the product property, the quotient property, and the power property. I'm not concerned with you knowing those names, but the names make sense. Really, there's not a whole lot of ambiguity with them because the product property simply says that if you have two logarithmic expressions, like you can see here, we've got the log base b of m plus the log base b of n, you can combine them as long as the bases are the same. So the b value has to be the same. You can combine them and make them the logarithm base b of the m and n together, being multiplied together. So whenever you have two logs being added together, we see that over here on the worksheet in number 1, and that's how we'll combine those two. We're going to use this product property right here. In number 2, the quotient property is the same idea, except now we're subtracting the two logarithmic expressions. They both have to have the same base. Their b values have to be the same. And if that's the case, then you can take the m and the n value and divide them in order to combine the two logarithms together. We can see that in number 2 and in number 3 over here. And then the power property, this one is a little bit different in that you're just working with one logarithmic function, but it's a logarithmic function that has a coefficient. That's what the n right here is showing. If you have a logarithmic expression that is being multiplied by a coefficient, you can take that coefficient and move it up here to the m and make it an exponent. So you'd be taking this right here and moving it over to become the exponent on m. And that's what we see in number 4. So let's go ahead and work through those, and we're going to match them with the different forms. So we're just changing their form is all we're doing. We're combining 1, 2, and 3 together to come up with one of these forms down here. So in number 1, since we see that addition sign there, we can see that the base isn't written, so the b it is not written right here. It's left open. So when it's left open and there's nothing written there, we assume it to be base 10. And so it doesn't have to be written when it's base 10. You can see that on all of these. They're all base 10. So because of that, we know they have the same base, and so we can use the product property to combine them. So when we do that, it would look like this. We would say the log of the square root of 2 times the square root of 8. Okay, so if you can see over here, we're not rewriting, we're going to make it all into one logarithmic expression. So we're going to combine them so that now we're just writing the log one time, and we're going to set the m and n values to be multiplied together. We know now if we go back to our radicals, our rules on those, that we can, as long as they have the same index, which these do, they're both square roots, we can multiply them together under the same radical. And in this case, we'll get the log of the square root of 16. Well, we know what the square root of 16 is. We can simplify that. And so it just becomes the log of 4, which matches over here with letter C. So number 1 goes with letter C. So we'll move on to number 2. Here we see the subtraction sign. The bases are the same. They're not recorded, so that means that we assume it to be base 10. And so because they are matching, we can use the quotient property, where we're going to write log, and we're going to take the m and n value, the 4 and the 10, and we're going to set them over each other. We need to go in order. The first one, the 4 is going to be in the numerator. The second one after the subtraction sign will be in the denominator. So we just need to make sure we keep those in order. If we look here, we see that it doesn't match any of these. Let me cross C out. We've already used it. But if we reduce 4/10, which we can, we're just going to simplify that fraction, then we end up with the log of 2/5, which does match with letter A here. So number 2 goes along with A. Now number 3 has a subtraction sign, so we know we're going to use the quotient property. But we're also, look here at the first term, that 2 log 4. that 2 is being multiplied by the logarithm of 4. So we have a power property that can be used to simplify that expression as well. This coefficient 2 is going to become the exponent on 4. And that's what we see down here in this power property. So I'll rewrite that as the log, again, base 10. We're just not writing that. And that 2 will just swing up here and become the exponent on the 4. And then we'll subtract from that the log of 2. And then the log of 4 squared. So we're not done. We've got to keep simplifying. The log of 4 squared is the same thing as the log of 16. And then we still have that minus log of 2. And now we have it in a form that we can go and use the quotient property. Again, we're looking for making sure the bases are the same. They're both power of 10. And we'll write the word log, and then we will take the 16 because it shows up first, and then the 2 goes in the denominator. And again, we're going to just simplify that fraction to be the log of 8, which matches here with letter D. All right, and then number 4, we only have one logarithmic function. So we're looking at a power property, potentially. We look here, we see it that there is a -3 coefficient, so we're going to swing that -3 up and make it the exponent on the 1/3. I'm going to put the 1/3 in parentheses. So now we have a negative exponent though, so we can't leave our final answer with that negative exponent there, so we're just going to follow the exponent rules. If we raise, well, we probably should let's just reciprocate it first. Okay, so if we reciprocate that 1/3 to get rid of this negative power, then we end up with positive, with 3 raised to the 3rd power, positive 3rd power, and we know that that is 27. So the log of 27 is what we end up with in simplified form. And so that goes with our letter B there. So in 1, 2, and 3, we actually combined 2 logarithmic expressions to make one. In number 4, we just changed the form on it. In number 3, we had to change the form on that first logarithmic expression so that we could combine them. So just they all have kind of like a different function, a different way that they work in each of the problems, these properties. So moving down the page to 5, here they have given you in the directions the approximate value for the log of 4 and the approximate value for the log of 7. And they ask us to evaluate the logarithm. So we can do this pretty easily without using a calculator, but we're going to go use these product properties backwards. So now if I look at number 5, I have log base 10. Again, it's not written, but it's assumed. So log base 10 of 28. So that, if we look at that and we look over here at the product property, and we're down here at this form right here. Log base B, the product property, MN. So what we can do is we can split 28 up into the product of 7 and 4. 7 and 4 makes 28. So we can rewrite this as the log of 4 times 7. This means the same thing as the logarithm of 28. And then we can use the product property to split them apart further. So that would be the log of 4 plus the log of 7. So I'm just using this product property, and instead of combining like we did at the top, we can, like number 1, we combined 2 logarithmic functions. Now I'm going backwards and taking one logarithmic function and splitting it apart into 2 that are being added together. The benefit of being able to do that then is now I can look up here and see that the logarithm of 4 has a value of 0.602, and the logarithm of 7 has this value right here, and I can take those 2 values, add them together, and get the logarithm of 28. I can do something similar with number 6. Now I have the quotient property. I have the logarithm of 7 over 4. So that goes along with our green quotient property over here. I can take those two logarithms and I can split them apart into a difference. So I'll take the logarithm of 7, subtract the logarithm of 4 from it, and now I can go up and use these approximations. 0.845 minus 0.602, and that will give me 0.243. Logarithm of 16 is the product of 4 times 4. All right, so 4 times 4 is just another way of writing 16. So now we'll use the product property, and we're going to split those two multiplication problems up into the logarithm of 4 plus the logarithm of 4 again. And so now we're going to add 0.062 to 0.062, or you could just say 0.062 times 2, and we would end up with this answer right here for the logarithm of 16. Moving on down the page to 11, here they're asking us to expand the expression, which is pretty similar to what we just did on 5 through 7. They're not giving us the value of any of the logs. They're not approximating any of those. So we're really just expanding the expression using the three properties of logarithms. So in 11, we see now here the base is not 10. They have a 3 recorded down here as that subscript. So that tells you your b value here, your base is 3 here in this one, okay? So that doesn't change anything about the way we're going to expand it, but I just wanted to point that out to you because up to this point, they have the b has been missing, and so we just assume it to be 10. But here the base is going to be 3. So we're going to expand this right here, this 3x, the 3 and the x are being multiplied together. So we're going to need to use the product property to pull them apart and expand the expression. We're going to write that one logarithmic function as 2. So we'll have the log base 3 of 3. And if we're multiplying here in our one expression, that means when we pull them apart, the two logarithmic functions are going to be added together. So we're just doing the opposite of what we're doing at the top where we're combining two expressions. Here we're going to pull them apart using that product property. And number 12, we're going to expand them by using the quotient property. So we have the log of 2x divided by 5. We know division, it means we're going to subtract the separate logarithmic functions. So we'll have the logarithm of 2x. I'm going to put that in parentheses. You'll see why in a minute. And the logarithm of 5 minus the logarithm of 5. Now this logarithm of 2x looks very similar to this log base 3x over here in number 11. We have a 2 and an x being multiplied together, so we can actually separate those out, expand those out as well. That multiplication, so we're going to use our product property instead of our quotient property. So we'll say log base 2 plus the log of x, I said base 2, I mean log of 2, plus log of x minus that log of 5 that we had originally. And so this is that expression expanded. All right, and then on 13, here we have an x raised to the second power. So that you can see the power of a property, the power property right there. And then you can also see we have the x squared being multiplied by y. So you can see the product property as well. So let's go ahead and split up the x squared and the y first. So we'll do that by writing two logarithmic expressions. Since they were multiplied together, to bring them together, we're going to pull them apart by writing two separate functions that can be added together. And we can still further expand this log base 7x squared because of the power property. So we can take this exponent and swing it down in front of the logarithm expression to be that coefficient. We did the reverse at the top of the sheet. We took the coefficient and swung it up to be the exponent. But here would be the logarithm completely expanded out. 14 is very similar to 13, except now we have an x squared being divided by a 4. So we're first going to write out two logarithmic expressions. They're going to be subtracted from each other. And now to further simplify this first one, we're going to take that exponent and swing it down in front of this logarithmic expression. And so this would be the fully expanded logarithmic expression for that one. All right, let's skip over to 16. We'll come back to 15 in a minute here. Log of 5 times the cubed root of x. So we have multiplication. We're going to split the two things being multiplied up into two logarithmic expressions. Now, log 5, that's all we can do there. But over here, watch, if we turn that cubed root of x into exponential notation, if we write it instead as x to the 1/3 power, and of course we keep rewriting this log of 5 on each line. Now you can see we have a power property. So we've got this exponent here that can be swung down in front of the expression and written like this. And then of course, don't forget to rewrite your log 5. And that's completely expanded there. Now if we back up to 15, you don't see the word log in here, or the expression log. You see this ln, which corresponds to the ln on your calculator. It's the natural log. That's what this refers to. And this is just shorthand, a shorthand way of writing this right here, log with a base of e. E being Euler's number that we discussed a few sections ago. So it can be expressed like this with log base e, but it's more commonly shown with the ln symbol for natural log. So that's what we see over here on number 15. We really are not going to treat it any differently as we're expanding this. We can expand the natural logarithm by first notating, now this is a little bit more challenging to see possibly, that we're going to need to split the x and the y up from each other, and we can do that because they're under the same radical. So we can say the natural log of x, square root of x, plus square root of y. Okay, and then from here, this looks really similar to this over here, the log of the cube root of x. We don't want to leave it with this radical here because we can do more work on it to expand it out. This could be the x to the 1/2. This could be y to the 1/2. And then we can follow the power product property and swing those exponents to the front of the expression. And this right here is the final form expanded out as far as we can go. All right, on the back side, we're now going to do the opposite of expanding the expression, and we're going to condense the expressions. We're still using the same three properties. In number 20, we have addition signs in between each of these, so we know we're talking about the multiplication. We're going to be using the product property. And the first thing we need to check for is making sure that our bases all match. So here we can see the base of 3 for each one. So we can go ahead and combine all these with that product property. So we'll write log one time. And then in parentheses, in base 3, I'm going to write the 4 times that 2 and times that 2 again. And then when we multiply those together, we'll get the log of 16. log base 3 of 16. Same thing on 21. We have addition signs in between each of those three expressions. The base is not written, which means it's 10, so they all match. So we'll write the word log, and in the parentheses, our product will be, okay, 4 times y. Let me get that one. I need to do one thing in here. Right here, we need to use the product, the power property, to take this coefficient over here and swing it up and make it the exponent on our x. So instead of x, it's going to be x cubed. And then that will be multiplied by that y. All right, and then of course we'll finish that off by actually multiplying those three together. So there we have condensed the expression. In 22, we have an addition sign and a subtraction sign. We also have a coefficient in front of our logarithmic expression, so we're going to swing that up to be the coefficient on, the exponent on x. So we'll rewrite just this one as log x to the 1/2. Again, we're checking bases. None of the bases are recorded, so that means they're all 10. So they match, so we can combine these together. And so we will combine these first two expressions as a combination of a product. So the log 3 times this x squared. I'm sorry, not x squared, x to the 1/2. And then that whole thing, that addition combination, is going to be divided by the log of 5. And so now, because we're condensing it, we're not going to leave that fractional exponent here. We're actually going to rewrite that as the square root of x. And again, putting the entire numerator over that denominator of 5. So this is the combined condensed expression of those three logarithmic expressions. In 23, we're dealing with the natural log again. So again, that's just a different way of writing log base e. And so we're going to follow the same rules, though, as if it were written as log base e. And we're going to take that 2 and swing it up, make it the exponent on the x. And then I'm just going to rewrite the rest of it. And so now we can see that we have a subtraction problem first. So we're going to take care of that first by combining those two. Those are going to be the natural log x squared over 3. And then we're going to add to that. I'm sorry, we're not adding to that. We're going to multiply because we do have addition here with the ln6. So that is just going to be expressed by that multiplication sign of 6. So we're taking care of the first two with the division, and then the last one we're going to multiply that on. That's a little bit different than number 22, where we had to take care of the addition first by making a multiplication expression, and then we took care of the subtraction by dividing it out by that last expression. So here we don't want to leave it like this, because we know we can write it, go ahead and multiply that 6. It's really 6 over 1, right? So we're going to have the 6 in the numerator, the 3 in the denominator, and then we can still even go further by reducing that fraction to 2. And so this would be your final condensed expression. Now the last thing we need to talk about is something called the change of base formula. And this is very useful when you're attempting to solve these logarithms with a calculator. On your calculator, the log button assumes that your base is 10. So if you can see on number 26 through 28, our base is not 10 on any of these. So we can't put this into the calculator in this way. You can't just hit log 12 and get the correct answer, because it's going to assume that your base is 10 here. So what we can do is use the change of base formula to actually change the base so that we are able to put it into the calculator. So the change of base formula, make sure you write this down, follows this pattern, this formula. Log base C of A equals log base B of A over log base B of C. So I know that looks very foreign right now, but we're going to use that for these three problems here, and it'll become a little clearer as we move along with that. If we look at 26 and we just kind of match, like I'm going to take this log base C of A and write it in down here underneath our problem. And then we need to identify our variables. So in this particular problem, A is 12 and C is 7. We can see over here in the formula we have a B that we need to come up with. So you have two options for a B value. You can either rewrite these as base 10, and if it's going to be base 10, then your B will be, of course, have the value of 10. In the calculator, then, you're able to use the log button. The other option that you have is to, instead of writing a log function, you could write, which this is just the common log. Anything to the base 10 is called a common log. You can also switch it to a base of E, because that's the ln button. If you have anything with a base of 10, we're talking about an expression that has its base as E, Euler's number. So you could also rewrite this as a natural log function. We're going to write these right now with base 10 because this works, and then we can use the log button. We just won't be able to use the ln button for these. So if I come out over here, I'm going to write log. My base I decided was going to be 10, but I don't have to write it because when we don't write it, that means it's 10. So my A was 12, and I'm going to put that over the log, again, base 10 of C, which in this particular problem is 7. Now I can go to my calculator and I can plug this in and get an answer out. So that will look like this on your calculator. You'll hit your log button, it'll pop up with the parentheses, put in your value of 12, end parentheses, divide, log again, 7, and end parentheses, enter. And again, for logarithms, we're wanting to round our results to 3 decimal places. So we're going to take this answer out to 1.27. This 9 tells us to round that 6 up, so it'll be 1.277. All right, we'll do the same thing. I'm going to write the pattern underneath our problem here just to make it a little bit easier for now to identify our variables. Our A is going to be 112, our C is going to be 4, and our B, we're going to use the log button. So I want to make my base 10 so that the log button on the calculator actually works properly. So I'll come over here and follow the pattern. Log base 10. I'm not going to write the 10 though. 112. Log base 10, 4. And then I'm going to go back to my calculator and do the same thing again. Log. Make sure you close the parentheses at the end of each of these. And again, we're going to round that to the nearest thousandth place, so it'll be 3.404. And last one, write the formula underneath, identify my A, my B, and my C, and then log 1.25 divided by log 5. Yours should look like my screen when you're done, and we will round that to 0.139.